Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 2654, minimum number of operations to make all elements equal to 1. Okay, you are given a zero index array nums consist of positive integers. You can do the following operation on array any number of times. Select an index I such that it lies between 0 and n minus 1 and replace either nums of I or nums of I plus 1 with their GCD value. Okay, return the minimum number of operations to make all elements of nums equal to 1. If it is not possible, then return minus 1. The GCD of two numbers is the greatest common divisor of two numbers. Okay, let's look at the examples. Okay, so 2 6 3 4 we have been given this. Okay, so the GCD of 3 and 4 is actually 1. So here they have replaced this element with 1 and then this is the array. Okay, now the GCD of these two numbers is actually 1 and then they have replaced 6 with 1. So this is the array, right, after transforming. Now GCD of these two numbers is 1, so they have replaced it, and then GCD of these two numbers is 1 and then they have replaced 4. Okay, so the total number of operations required here is actually 4. Okay, so if you clearly observe, the moment you have 1 in the given array, okay, that means all other elements can be easily transformed into 1. Okay, because GCD of any number with 1 is all will always be turned out to be 1. So all the elements in the array can be converted into 1. Okay, so the moment you have 1 in the array, that means all other elements can be converted into ones. Okay, so there is a possibility that there will be single one or there can be more than one ones as well, right? So the total number of ways operations required to convert is basically the length of the array minus the number of ones in the array. Okay, so let's take, let's say this is also 1. Okay, so that means you don't have to convert this 2 into 1 because it's already 1. Okay, so the operations required will be to convert this and to convert this, so only two operations will be required. Okay, so in that case the number of operations will be n minus 2, which is 4 minus 2, which is 2. Okay, so this is the first use case. Okay, and if you see this particular test case, the greatest common divisor of all these numbers is actually 2. Okay, so if the greatest common divisor of all the input array, if it is greater than 1, that means we cannot convert all of these into ones. Okay, if the greatest common divisor is not greater than 1, okay, that means if the greatest common divisor of all the numbers turns out to be 1, okay, that means there we can actually convert the array. There's a possibility that we can convert this array into ones. Okay, so how can we identify the number of operations in this use case? Okay, so what we'll do, we will try to, let's take this particular example. Let's take GCD of these two numbers. GCD of these two numbers is 2, so let's assume that I'm converting 10 to 2. Okay, and then I will take GCD of these two numbers, which will turn out to be 1, and then it will convert. I'm just replacing 15 with 1. Okay, now that I have reached an array state where I have I have ones in the array. Okay, now this state is actually equal to this state, so I know the number of operations required will be length minus 1. Okay, so here if you see this entire sub array, because I'm taking GCD of these two numbers, I'm taking GCD of these two numbers is 2, and then with the GCD I'm taking the GCD of the next along with its next number. Okay, so indirectly I'm taking the GCD, I'm finding I'm finding an array whose GCD is actually 1. Okay, now that I found a GCD I found a sub array whose GCD is 1, so the length of this array is actually 3. So the number of operations required to convert from here to here is actually the length of the subarray minus 1. Okay, so if you see the length of the subarray is 3, 3 minus 1 is 2. If you see, these are the two operations which I have done, right? So The idea here is to identify the shortest subarray whose GCD is 1, and then so once you identify the shortest subarray, in order to identify the shortest subarray, we have to perform these many operations, okay, which is the length of the shortest subarray whose GCD is 1 minus 1. So if we perform at least these many operations, then only you can identify the subarray, and then we can convert the array into this particular form. The moment you have converted the given array into this particular form, from here to reach this state, the number of operations required will be length minus 1. Okay, let me jump back to the code and show you what I have implemented. Okay, so the same, I'm just in the flow I have explained you the same way I have implemented. Okay, if it contains any ones or not. Okay, so as initially I was checking if there is any one, that means the number of operations required will be n minus number of ones, right? So I'm checking are there any ones in my given array, and simultaneously I was also trying to identify the GCD of all the numbers, because while traversing to the given array I was also keeping track of what is the GCD of all my elements. Okay, the moment I have done iterating through the entire array, if the number of ones is greater than 1, that means if there is at least one in my array, okay, so the number of operations required will be n minus the number of ones. Okay, if this condition is not satisfying, that means there were no ones in my array. Okay, that means there were no ones in my array. If my GCD turns out to be greater than 1, okay, if my GCD turns out to be greater than 1, that means I cannot convert my array to all ones, so that means I have to return minus 1. Okay, if I have crossed this particular statement, that means I can convert my array into all ones. Okay, now I have to identify what is the operations required, right? So as I mentioned, we are supposed to identify the shortest subarray, right? So when I say the shortest subarray, right, the length of a subarray, either it will be ranging from 1 till all the way to the end. So I have defined a variable called minimum length, whose length is equal to the length of the array, and then I'm just iterating from 0 to n, and then I'm generating all possible subarrays. Okay, so this particular two statements help me to generate all possible subarrays. Okay, now for each subarray I'm trying to identify the GCD. Okay, the moment I identify the GCD of a particular subarray, if it is 1, okay, that means I have identified a shortest subarray whose GCD is 1. Okay, and then I will just break my loop. Okay, that means I've identified a subarray whose GCD is 1. Then the total number of operations required will be min length minus 1 plus num minus 1. Okay, so this is my final answer, right? So I've just written it, I just summed up 2 minus 1s and then I've written it as a consolidated. So this is the total number of operations required. Okay, I hope you guys are aware about how to calculate the GCD. If not, you can Google it. Okay, it's pretty simple. Okay, this is the iterative approach of finding GCD, and this recursive way, and this is the iterative way. Okay, so yeah, I hope let me submit this problem. Okay, this should work. Yeah, it has satisfied all the test cases and it has beaten 100% of the solutions. Okay, yeah, so I hope you have understood the thought process behind the problem. Do subscribe to my channel for more such coding videos. People are not subscribing to my channel but still consuming. I highly recommend you to subscribe so that you won't miss any of my videos. Okay, so let's also analyze the time complexity over here. Okay, so if you see, we are trying to generate all possible subsets and calculating the GCD for all those possible subsets. Okay, so the number of time complexity to generate a particular subset, all the subsets is basically order of n square. Okay, and then we are also calculating the GCD of two numbers, right? So the GCD would be like can be calculated in log of the maximum of those two numbers, and then the time complexity to generate the subsets is basically order of n square. So the overall time complexity will be order of n square log m, where m is the maximum of both two numbers. Okay. Space complexity will be constant because we are not using any extra space here. Yep. That's all about this problem. Thank you.